For years, Ford's 5.0-liter Coyote V8 has been celebrated as one of the most exciting engines in the American performance world. It powered everything from the Mustang GT to the F-150, delivering a rare combination of strong horsepower, razor-sharp throttle response, and the unmistakable sound that only a naturally aspirated V8 can provide. While many automakers turned toward smaller turbocharged engines, Ford continued investing in a high-revving V8 that enthusiasts genuinely admired. The formula worked. The Coyote became a favorite among racers, tuners, truck owners, and everyday drivers alike. But hidden beneath its reputation was a problem that followed the engine for years. It wasn't a rare defect affecting only a handful of vehicles. It was an issue discussed across enthusiast forums, mentioned in countless repair shops, and debated endlessly among engine builders. For a significant number of owners, the Coyote developed a reputation for excessive oil consumption and premature cylinder wear. Although the engine delivered impressive performance, questions about long-term durability continued to surface. Many owners found themselves checking oil levels more often than expected. Some reported noticeable oil loss between service intervals. Others experienced symptoms that pointed toward internal wear long before they believed an engine should begin showing such signs. The issue became serious enough to generate technical service bulletins and legal scrutiny. More importantly, it created uncertainty among buyers who otherwise loved the engine. The causes were complex. Ford's advanced plasma-transferred wire arc cylinder liner technology offered weight savings and efficiency benefits, but it demanded extremely precise operating conditions. At the same time, the engine's lightweight pistons and relatively short skirt design helped reduce friction and improve responsiveness. The downside was that under certain conditions, piston stability inside the cylinder could suffer. As engine speeds climbed, side-loading forces increased. Combined with aggressive factory tuning and years of repeated high RPM operation, some engines experienced abnormal cylinder wall wear. Once wear patterns developed, ring sealing could become less effective, leading to oil consumption and further degradation over time. One experienced builder summarized the challenge perfectly. The Coyote was designed to behave like a performance engine while surviving the workload of a daily driver. Balancing those two goals is never easy, and in earlier versions of the engine, oil control often became the weak point. For Mustang owners, the concern was frustrating because the engine otherwise felt exceptional. For F-150 owners, the problem raised even larger questions. Truck buyers expect durability. They expect engines to handle towing, hauling, long-distance driving, and years of hard use without developing significant internal issues. Oil consumption simply did not fit the reputation most buyers wanted from a modern truck engine. Ford eventually faced a decision: either abandon the architecture and pursue an entirely new design, or revisit the existing engine and solve the underlying problems. The company chose the more difficult path. Beginning with later revisions and continuing into the newest generations of the 5.0-liter V8, Ford quietly introduced a series of engineering updates aimed directly at the root causes of the problem. One of the most important changes involved the pistons themselves. Engineers redesigned piston geometry to improve stability within the cylinder bore. By reducing unwanted movement and minimizing piston rock, Ford addressed one of the key contributors to cylinder wear. The piston rings were also revised. The updated ring package provided improved oil control while maintaining the low friction characteristics necessary for performance. Rather than focusing solely on reducing oil consumption, engineers worked to create more consistent behavior throughout the engine's entire operating range. The goal was stability. Whether the engine was idling in traffic or approaching redline, the piston and ring assembly needed to maintain proper sealing and predictable operation. The results proved significant. Newer engines demonstrated improved oil control, better ring sealing, and more consistent wear characteristics throughout extended use. Ford also refined the manufacturing process used for the cylinder liners. Tighter production tolerances and improved surface consistency helped create a more uniform environment for the piston rings to operate. This reduced the likelihood of uneven wear, developing over thousands of miles and improved long-term durability. Independent engine inspections have helped support these improvements. Builders examining high-mileage examples of newer Coyotes frequently report cleaner cylinder walls, stronger compression retention, and noticeably reduced signs of abnormal wear compared to some earlier versions. These findings suggest that the improvements were not cosmetic changes or minor revisions. They represented meaningful engineering, corrections aimed directly at the engine's known weaknesses. Another important update involved engine calibration. Earlier versions of the Coyote prioritized maximum excitement, particularly at higher RPM ranges. While the aggressive tuning delivered excellent performance numbers, it also increased stress on internal components. Ford's revised calibrations sought a better balance. Power delivery became smoother under demanding conditions, thermal management improved, and the overall operating environment became less stressful for the engine's rotating assembly. Performance specialists familiar with multiple generations of the Coyote often note that the newer engines feel more refined while still retaining the character that made the platform popular in the first place. Importantly, these changes did not come at the expense of performance. The engine remains responsive, eager to rev, and capable of producing impressive horsepower figures. The difference is that it now does so with greater confidence in its long-term durability. Real-world ownership experiences increasingly reflect that reality. Many high-mileage examples of the updated Coyote continue to show stable compression numbers and minimal oil consumption even after years of use. Repair shops that once regularly encountered oil-related complaints now report seeing far fewer cases involving the newest versions of the engine. One performance shop owner offered a simple observation. The updated Coyotes rarely return with the same oil issues that plagued some earlier models. That statement alone speaks volumes. For Mustang buyers, the modern Coyote represents one of the last great naturally aspirated V8 performance engines still available today. With more than 480 horsepower in current applications, a broad aftermarket ecosystem, and significantly improved durability, it delivers the kind of experience many enthusiasts fear may eventually disappear from the market. Drivers can enjoy the engine's high-revving personality without constantly worrying about checking oil levels or monitoring potential wear concerns. For truck owners, the benefits may be even more important. The improved 5.0 offers stronger long-term confidence for towing, hauling, and everyday work duties. Better oil control and enhanced durability make it a more appealing option for buyers who plan to accumulate substantial mileage over the life of the vehicle. As a result, the naturally aspirated V8 remains a compelling alternative to smaller turbocharged power plants. There is also a broader industry story unfolding here. Automakers across the world continue facing increasing emissions regulations and accelerating pressure toward electrification. Large displacement V8 engines are becoming less common with every passing year. Against that backdrop, Ford's decision to continue refining and improving the Coyote carries additional significance. Rather than abandoning the engine, the company invested resources into making it better. That decision suggests Ford still sees value in preserving V8 performance as long as customer demand remains strong. The latest version of the Coyote provides a foundation for future performance vehicles while demonstrating that internal combustion technology can still evolve through careful engineering and continuous refinement. Perhaps the most interesting part of this story is how quietly it happened. There were no major announcements, no massive marketing campaign, no dramatic reveal. Ford simply identified the engine's weaknesses, redesigned critical components, improved manufacturing processes, refined calibration strategies, and allowed the results to speak for themselves. By addressing piston stability, ring sealing, cylinder wear characteristics, and overall engine behavior as a complete system, Ford transformed the Coyote into a far more durable and dependable platform. Today, the 5.0-liter Coyote stands as something its earliest versions never fully achieved. A high-performance V8 that delivers thrilling power, everyday usability, and the long-term durability owners always wanted. Fast, refined, capable, and finally, engineered to last.